An outer space spectacular that was the stuff of dreams only a generation ago began snapping into the sharp focus of reality today. After its billion-mile journey from Earth, the Voyager 1 spacecraft sent back pictures of man's closest look yet.
Voyager 1 has not stopped to amaze NASA scientists and the general public as a whole. Launched 45 years ago, Voyager 1 has long exceeded its lifespan. Still, it's presently exploring space regions that it wasn't built to explore and sending data back to Earth. It sends data back to Earth using outdated technology that's worse than a vintage cassette player. And with this, it helped scientists to make a startling discovery. What could a dated space probe like this help uncover? Join us as we explore the terrifying discovery by Voyager 1 as it just turned back. Number 1. The shocking discovery Voyager 1 made. Voyager 1 was sent out into interstellar space to study the boundaries of the giant planets and the solar system, and also to keep on going far out into outer space to get magnetic readings and photos and send these data back home to NASA. Launched on September 5, 1977, nobody expected this probe to still be operating now and making new interstellar discoveries. 45 years have passed, and Voyager 1 is still going strong. In fact, because of Voyager 1, a great discovery that'll hasten spacecraft movements from Earth to Neptune was discovered. The discovery happened in 1965 when an intelligent NASA scientist named Gary Flandreau was planning how to map out the best path for a space probe to the giant planets, using a spacecraft that would now be known as Voyager 1. The giants of our solar system that were about to be studied were Uranus, Jupiter, Neptune, and Saturn. Having just a pencil and precision tool at his disposal that was fondly used by most engineers in the 20th century, Flandreau kept brainstorming for the easiest and most convenient path for his Voyager 1 spacecraft to fly to these planetary giants, until he stumbled into a stunning discovery. Usually, it'll take 30 years for a spacecraft from Earth to arrive at Neptune. However, something strange had happened. The stars, or should we say, the 4 giant planets now, had literally aligned in an unusual way on the cosmos that formed a celestial necklace linked to the Earth. Jupiter, Saturn, Neptune, and Uranus had formed a big round cosmic alignment, which means that any spacecraft passing through would gain an overwhelming speed boost from the pull of gravity released by each of these planets. Being the quick-witted man that he is, Flandreau quickly recalculated the time it'll take a spacecraft to reach Neptune from Earth under these new conditions, and he found out that the time has shortened from 30 years to 12 years. This new discovery meant that a new space probe had to be created in no distant time to take advantage of this opportunity, because it was discovered that this planetary alignment only happened once in 176 years. For the fact that space explorers can travel way faster because of this gravitational pull from the main solar planets, which sucks and pulls the spacecraft as if being tugged by an unseen rope, a quick interstellar explorer had to be developed quickly. And that was how Voyager 1 was created and launched on September 5, 1977. A twin space probe called Voyager 2 was also launched to follow Voyager 1 on August 20th, 1977. Number 2, Voyager 1 keeps startling scientists by breaking records till today. Considering the limited technological wirings built into Voyager 1 at that time, no one expected it to last longer than 4 years, as that was the projected duration of their mission. However, Voyager 1 went on to break all records and stun scientists by still sending useful pictures and cosmic readings from space for the past 45 years. After all this time, Voyager 1 is actively exploring virgin areas of outer space and the interstellar galaxies. The ancient space probe doesn't show major signs of slowing down soon, as it has even gone on to outlast all spacecraft in history created by NASA. It is also the probe that has traveled further than any other. Both Voyager 1 and 2 are getting strong signals that they send back to Earth to understand how our solar system and interstellar space are shaped. Voyager 1 is widely regarded as an interstellar space probe pioneer, as it continues moving at 35,000 miles per hour, taking readings from cold depths of space that are currently unexplored at over 15.5 billion miles away from the Earth. The readings, pictures, and messages sent by Voyager 1 now take 22 hours to reach the team at NASA. Among the pictures they sent back home that amazed the team of scientists at NASA were close-up views of Saturn and Jupiter's moons. The moons looked different from usual and revealed new realms that were more dynamic, volatile, and alive than anything we'd ever imagined. Inside these moons contained extreme weather conditions such as active, boiling volcanoes on one hand and freezing ice fields on the other hand. The Pioneer probe helped scientists to gain new insights into how these distant planetary bodies work. In 1986, Voyager 1 achieved another feat as the first spacecraft to go frighteningly close to Uranus. It completed its course with Uranus in the same year and headed towards Neptune in 1989 as it made its way out of the solar system. No other spacecraft has undertaken such a journey that far from the Earth before. Voyager 1 is often called the Earth's most distant emissary to the cosmos. Surprisingly, Voyager 1 is no bigger than a vintage Volkswagen Beetle, yet it has astounded scientists with its novel discoveries in uncharted territories in outer space. Due to the gravity assist from the huge planet of Venus, the record-breaking spacecraft received an incredible amount of gravitational push that aided it in its cosmic travels. Thanks to Gary Flandreau, who noticed this rare opportunity from hours of calculations and permutations, Voyager 1 is doing something that no other NASA spacecraft has ever attempted. Number 3. Challenges encountered by Voyager 1. This feat didn't come without its challenges, however, as the team at NASA recorded a considerable margin of error that measured tens of minutes and lots of attempts to correct these errors. Another challenge encountered was that Voyager 1's first trip to Jupiter landed it 10 times farther away from Earth than Mercury. To get back on its route, NASA's team had to carefully navigate Voyager 1 through the hazardous asteroid belt, as one wrong move could see the much-loved space probe crumble to pieces. Voyager 1 isn't the first spacecraft to have made its way through an asteroid belt. In the 1970s, 2 spacecraft known as Pioneer 10 and Pioneer 11 breezed past the dense asteroid belt through a thoughtfully crafted path carved out by NASA scientists. They came out of that episode without a scratch. Thankfully, these space travel predecessors paved a clear way for Voyager 1 to follow through. One more challenge that Voyager 1 had was a low memory of only 69 kilobytes, which was equal to a fraction of most smartphones' capacity. It seemed that depending on its onboard intelligence was the only way the Voyager 1 computers could wade through the complexities of its journey. 8-track tape recorders were used to store data that were collated by the instruments on board. After that, the data would be sent back to Earth in a measly 23-watt transmitter that has just as much power as a refrigerator's light bulb. Though Voyager 1 was loaded with a 12-feet-wide dish for radio communication for back-and-forth messages with NASA, and they traveled at the speed of light, it still took over 18 hours as it then for NASA to receive messages from Voyager 1. Presently, it takes 22 hours. The reason for this was because of the great distance the spacecraft had from Earth, as it speedily moved by around 4 light seconds daily. This presented trouble in maintaining the connection with Voyager 1 from NASA's base. Following from behind, Voyager 2 took a little more than 18 hours for its messages and data to reach the Earth. This was made even harder by the increasing interference from Earth's noise coming from television, radio, and cell phones, amongst others. These interferences were likely to drown the faint noises coming from Voyager 1 and 2. In spite of these challenges, Voyager 1 still went on to conquer new territories in the interstellar void and sent the reports back home, to the joy of scientists and researchers. The journey of the space probe writes new laws that continue to refine our understanding of the interstellar galaxies and planets. Number 4. The journey of Voyager 1. The mysterious art cloud was spotted by Voyager 1 far outside the solar system. The art cloud is a group of solar bodies that have the appearance of comets. They are firmly joined together by the gravitational pull of the Sun that runs halfway to the nearest star. As Voyager 1 slowly wades through interstellar space, it encounters solar wind phenomena that were brought about by heliopause. Heliopause is the border between the interstellar space and our solar system. Moving past, it would land the probe in uncertain, unexplored solar territories. Scientists quickly moved to calculate the distance between Voyager 1 and the heliopause, but the data turned out to be inconsistent. Assuming the distance was 50 astronomical units, the project's funding would have been increased. As Voyager 1 moved from our solar system into interstellar space, no scientific phenomenon suggesting that the spacecraft entered interstellar space was detected, as previously anticipated. One of the expectations scientists had for entering into interstellar space was high-energy particles emitted by supernovae, an astronomical increase in galactic cosmic rays, and tumultuous cosmic disturbance moving at the speed of light. One logical explanation for why there was no sign that Voyager 1 entered interstellar space is that there's a robust magnetic shield in the heliosphere that protects our solar system from most of the disturbances from interstellar space and outer space at large. Just to be sure, however, the Voyager team closely monitored and looked out for any changes in the dominant magnetic field as Voyager 1 journeyed further. Since NASA's team found out through Voyager that interstellar space containing ionized gases didn't have a different magnetic space from the heliosphere. As expected, Voyager 1 kept moving until it finally crossed the heliopause on August 25, 2012, and it sent data back home. It confirmed to the scientists that there had indeed been an increase in plasma density, but there was still no shift in the magnetic field. The scientists found it puzzling, as they had expected that a change in magnetic field direction would happen when moving from a region influenced by the Sun's magnetic field to another region influenced by only stars, such as interstellar space. Voyager 2 also launched out to the interstellar seashore in November 2018, reaching the heliopause at the solar system's border at 120 astronomical units from Earth. That was the same distance covered by Voyager 1 6 years before now. Like its twin predecessor, Voyager 2 also detected no magnetic field changes, in sharp contrast to the scientists' theoretical models on this. As both Voyager probes inched closer to the interstellar regions, small changes in the heliopause were influenced by the activities of the heliopause. When looked at from a vast scale, however, the change in the magnetic field was negligible. Scientists concluded that the Voyager probes hadn't yet reached the real interstellar magnetic field because of the absence of changes, and the spacecraft was still on the shores of interstellar space. NASA's scientists have taken two sides about this matter. One camp believes that the Voyagers are still in the heliosphere, and the other camp is of the opinion that both space probes are already in interstellar space due to the presence of the increased plasma density and galactic cosmic rays detected by the Voyager probes. Powered by outdated technology from over 50 years ago that needs a little software to operate, the Voyager 1 still travels bravely in space, doing amazing work of sending insightful data back. Voyager 2 has 5 instruments, unlike Voyager 1, which has just 4, and they both transform heat from plutonium's radioactive decay into electrical power. Right now, the power outages on both Voyager probes fall by approximately 4 watts annually, causing NASA to switch to a triage mode. To preserve its power, scientists shut off the heater powering the cosmic ray detector so it can keep functioning under adverse solar temperatures far beyond its tested limits. Scientists had predicted the plasma science instruments and the magnetometer as the final instruments to be knocked off since they're found inside the Voyager probes, receiving heat from the computers, unlike the other instruments mounted outside at the 43-feet-long fiberglass boom. If the power of the Voyager probes remains as expected, scientists might be able to continue their missions till 2030. Without the power, though, the Voyager 1 spacecraft would keep flying in space, going past the Earth's closest star called Proxima Centauri at 16,700 years, and Voyager 2 will accomplish the same feat 3,600 years later. These resilient spacecraft would still journey through space millions of years after the Sun and the heliosphere has faded away, along with the Earth. Thanks for watching to the end. Now you found out the interesting discoveries that Voyager 1 and its twin probe have made. Hit the like button, and don't forget to subscribe for more interesting video content.